Hi. The laws of exponents that you learned, it seems like there are so many of them. And how do you know which one to use? And how do you know if whatever you want to use is correct? So this video hopefully will help you organize all the ideas, stress some important hints, tricks, rules, and show you a few examples. So yeah, there are many of them. Not like many, but enough to get confused. So there are definitions. Definition of exponent when n is a counting number, 1, 2, 3, 4, 5, and so on. A to the 0 we know. Negative exponents, the keyword is reciprocal. And fractional exponent, the keyword is the radical. There are two ways to write this definition. Depending on the situation, you may prefer either one. So you really want to remember those. Okay, and the laws are properties that are derived from the definitions. They're proven that they work for any exponents. So when we have the same base and multiply powers, we add exponents. When we divide powers with the same base, we subtract exponents. When you raise power to another power, we multiply exponents. When you multiply two bases raised to a power, we can distribute, raise each base to this power. The same with division. Hopefully you remember them by now. If not, make an effort to memorize. But I want to give you a simple trick that will help you restore the rules if you need it, if you forget it. So here's my first hint, first principle. Okay, so the laws are the same for all exponents, negative, fractional, whole numbers. So if you're confused which law to use, or do you add exponent, do you subtract exponents, you can use some simple numbers to verify. Here's an example. So you need to raise x to 3/4 to another power, negative 5/9. Suppose you forgot. Do you add, do you multiply, do you subtract, what do you do? So this is not really easy to guess or like check if your answer will be correct for this example. So replace those bad fractions with nice numbers. Let's say x squared to the third power. It doesn't have to be negative because again the laws are the same. So suppose you forgot. So let's see what that means. X squared, this is xx. X, whatever cube this means multiplied by itself 3 times. It takes you a couple seconds to do, and then you see that you will have x to the 6, so you see clearly not only that you need to multiply 2 by 3, but also why you need to do that. So going back to this problem, you know that you need to multiply exponents, and I really like keeping my fractions in the fraction form, not using slashes, because that way we can easily simplify them. So we multiply fractions and we can reduce it. So 3 goes into 9 3 times. Ooh, and 5 and 4 don't go anywhere. Oh well. So you get x raised to the negative 5 in the numerator and 4 times 3, 12 in the denominator. We finished. If you need, in the end, you can rewrite it in a without negative exponents using the reciprocal idea. Negative exponent is the reciprocal, so it's 1 over x to the 5/12. If you want, if you need, you may need to write it in a radical form. So this is x, 5 is on top, and 12 is the denominator, so that shows you the root. But we usually don't do this. This is good enough. Okay, second idea. Exponents are more flexible, easier to simplify than radicals. So whenever you need to simplify radicals, switch to exponents. Example. So you need to multiply and divide some radicals, and who knows what happens with them because the radicals are all different. Of course, if it were like all the same type of radical, it wouldn't be that hard. We could just combine them all inside one radical. But in this case, they're different. So we're switching to fractional exponents. Third root of x is x to 1/3 because this is kind of 1. Then this is x to 1/6 and this is x to 1/2. We can luckily use properties of exponents to combine these radicals, these exponents, they all have the same base. So in the numerator, we add the exponents. So it's 1/3 plus 1/6. I can right away subtract 1/2 here, and that will be it, because I'm dividing by x to 1/2, so I need to subtract 1/2. All right, so I may want to do this addition separately. 1/3 plus 1/6. So the common denominator will be 6. So I need to multiply this by 2 to get a 6, and by 3 to get a 6. Oops. So I get 2 plus 1 minus 3. Oh, that's 0. Oh, so I have x to the 0 power, which is just 1. You see how with exponents it's like really painless. And so let's look at this example. As you know, third root is the same as everything raised to 1/3 power. I could write the entire thing raised to 1/3 power, or I can just distribute right away in my head and say x raised to 1/3 power, then y to the 6 raised to 1/3 power, and then z to the 7th raised to 1/3 power. So x to 1/3 is already simple enough. Here we are going to multiply exponents, so it will be 6 times 1/3, which is 6/3, which is 2. So just 2 squared, y squared. And z, it's 7/3. Maybe the answer is good as is. But let's look at this part more carefully. So z to the 7/3, we can rewrite this 7/3 in a mixed, as a mixed number. Z to the 2 and 1/3 power. What does it say? It says that we have z squared and also z to 1/3. So we can, again, we can leave the answer like this, or if you want the answer in the simplest radical form, actually let me replace this first to see what happens. X to the 1/3 y squared, and then I just put this in z squared, z to 1/3. So that is clear now that y squared and z squared are whole expressions, they don't need radical, but x and z are raised to 1/3 power, so we can just go back to the radical and write it like this. Okay, here's one more useful hint. Often people make mistakes because they're just not asking this question. What exactly is raised to that power? So let's practice asking this question. So maybe don't even ask. Just solve these few problems the way you would do without much thinking, and come back in a few minutes when you're done. All right. So suppose you are done and you solved all these problems. So let's see if you got them right. First question. First problem. What exactly is raised to 1/2 power? 9. You can see it because minus is not raised. Minus is not in parentheses. So 9 to 1/2 power is 3. It's a square root of 9, and the minus is outside. Second problem. What is raised to 1/2 power? -9. So that would mean square root of -9, which is not possible. Does not exist. Undefined. Okay. Now, in the third problem, 8 is raised to 1/3 power, and minus is just patiently waiting outside. 8 raised to 1/3 power is a cube root of 8, which is 2. Next problem, -8 is raised to 1/3 power. This is a cube root of -8, which is okay because it's an odd degree exponent, so it's really -2. Why? Because -2 raised to the 3rd power is -8, so that works. Okay, so these questions look very similar, but you need to distinguish these little differences. Okay, next a couple problems. Some may think that it's the same. No, they're not. So in the first problem, only x is raised to -1 power, and 2 is not. So 2 is not in the denominator, and x is. And in the second problem, both of them are raised to -1 power. So we need to take reciprocal of the entire 2x. So 2x is on the bottom. Tricky, right? Now, next problem. 4 and x both are raised to 3/2 power. So we need to raise 4 to 3/2 and x to 3/2. I didn't leave enough room for this. So 4 to the 3/2 power, 4 to 1/2 power. It's a square root of 4, which is 2, and raised to the third power is 8. And this is just what it is. So this will be the answer. In this problem, 4 is not raised to any power. It's just x. So if you really need to, you can rewrite it as in a root form, but essentially this is not simplifiable. Again, look at the differences. Ironically, students usually get this wrong and get this wrong. Why? So in this case, it seems like so tempting, -1, reciprocal, you just send the entire thing here downstairs. And in this problem, maybe because people don't want to distribute, they think that it's just a 4 and x raised to the 3/2 power. So again, the common mistakes are this. People are doing this way, and people are doing it this way. Okay? So I hope you're not one of those. Okay, the next quick hint. When you have negative exponents and fractional expressions, this is really useful. Negative exponent means take the reciprocal, which just says switch the level. If you have x raised to -3 power, it means 1 over x to the third. So instead of being on top, you can visualize it like this. It goes on the bottom. Now, when your expression with a negative exponent is already on the bottom, it switches the level, it goes on top. Okay, and then we don't need really a bottom. Why is that? You can look at this as a reciprocal of the reciprocal. So you flip the fraction. You can look at this as a division problem. I'm sorry, it was x cubed here. You can divide 1 by 1 over x cubed, so you have to multiply by the reciprocal. Or you can just think about negating twice. You can think about this being x negative third to the -1, because that's a reciprocal, and then you get x cubed. All right, so with these few hints, we are going to do one problem which will utilize all these ideas. Okay, let's solve this problem. First, copy it down on paper and simplify it by yourself as much as possible. When you finish, come back. All right, so suppose that you finished it. What did you get? Okay, we're going to check it. So we're going to ask this question. What exactly is raised to each of these powers? First guy, what is raised to 2/3 power? Is it 8x? No, just x. 8 is just waiting outside, so it's still waiting. And x is, okay, I could write it in radical form, but I really don't want to. Imagine I'm going to include radicals instead of all these exponents. Third radical, fourth radical, and then what am I going to do with them? Exponents are more useful, more flexible, so we will not will not use definition yet, maybe in the end. Next question. What is raised to -3/4 power? Is it 9y? No, just y. So we keep the 9. Now, I don't want to copy y to -3/4. It's my negative exponent. So remember, negative means reciprocal. So instead of being negative on top, it will become positive on the bottom. It doesn't matter where I write it on the bottom. I'll just write it right here. Okay, pause and look very carefully what I did. Okay, so basically what I did, I rewrote this in this form. 9 is not raised to any negative power, and y is. Okay, let's look at the bottom now. What is raised to 1/4 power? The entire thing. So I need to use my property that says each of the factors must be raised to 1/4 power. So I'm going to write 16 to 1/4 and y to 1/4. And finally, what is raised to -1/3 power? The entire thing. Therefore, I need to apply this exponent to each of these guys. But my thing is negative. So instead of distributing negative exponent on the bottom, I'm going to distribute positive exponent on top. So I'm going to send both of these guys raised to 1/3 power on top. I could split it in two steps, but I hope you understand what I'm doing. So 27 raised to 1/3 and x raised to 1/3. So I did two things here. First, I use that property that each factor raised to m power, power of m. And the second, I applied my negative reciprocal definition. So I sent this base to opposite power to a different level. Okay, first big step done. Next hint, which I did not write as a separate, like, big deal, but always work with one thing at a time. What I mean by this, work with numbers separately, work with x's separately, work with y's separately. Okay, so let's do this. And as we go, we may need to simplify a few things. So let's take care of the numbers. 8 is just 8, 9 is just 9. 27 is raised to 1/3 power. So this is a cube root of 27, which is 3. And I have it's not 16, it's 16 to 1/4 in the denominator. So this is 4th root of 16, which is the 2. Okay, we used all the numbers. We'll simplify it all in a moment. Now let's look at the x's. So x on top, we have x to 2/3 and x to 1/3. So because they're powers of the same base, we can just add exponents. And finally, we have a couple y's on the bottom. And again, we just add exponents, 3/4 plus 1/4. All right, so now we simplify 8 and 2. 8 divided by 2 is 4. 4 times 3, 12 times 9, 108. X 2/3 plus 1/3 is just a 1, so I don't write it. And y 3/4 plus 1/4 is 1 also. Y on the bottom. That's it. Look, it's pretty painless. If you follow all these steps, if you remember all these little tricks. Okay, good luck simplifying.